Hello and welcome to AWS Innovate, our special edition on artificial intelligence and machine learning. This is our live opening keynote, so I want to remind you that throughout the platform and throughout the day, you can submit questions in. We'll have a team on standby that will be able to answer those questions. My name is Olivier Klein. I'm the Chief Technologist here in Asia Pacific for AWS, and today what I want to talk to you about is how can we actually start innovating faster and make our businesses more efficient using artificial intelligence and machine learning. Now, to help me with this opening keynote, I'm also having with me Dean Samuels, our Chief Architect based out in Southeast Asia. So let me switch over to Singapore and see if Dean is online. Hey Dean, can you hear me?
I can indeed, Ollie. How are you going? Greetings from Singapore. Absolute pleasure to be with you today to talk about everything machine learning.
Yeah, super excited to always run the opening and later also the closing keynotes with you out of 2 studios in different parts of the world. That is really cool. Now, with that in mind, though, as a technologist, I always like to look at new technologies. I'm super excited about things that are happening in the deep learning space, in the artificial intelligence, machine learning space. But I also always say, you know, there must be a reason on why we are creating and using technology in a certain way. And that is really about driving certain business outcomes. And the same thing applies here if we talk about artificial intelligence and machine learning. Today we'll share a lot about the art of the possible, but with a strong focus on business outcomes. Isn't that right, Dean?
Yeah, absolutely, Ollie. And you made a great point that, you know, as technologists, we love playing with that technology and really seeing how this technology can allow customers to have such a significant impact to their industries. But it really does start with that business outcome. And what we found over the many years that we've been involved in machine learning at AWS is that we've reached a tipping point of where machine learning is really having that impact across businesses, across industries. And it can be broken down into 4 key categories. First of all, you have machine learning's impact on the ability to enhance the customer experience. So organizations can actually leverage a lot of the data that they're collecting about their own customers to really provide a very personalized approach to those customers and really differentiate them from their competitors. Organizations are also able to do better and faster decision making because now they can be a data-driven organization and they can react very quickly based on the data that they're receiving, almost in real time in some cases. Machine learning allows that. And then businesses and organizations are able to improve their overall business operations, whether it's along the supply chain or whether it's around how they actually respond to their own customers by leveraging the data they're collecting. Machine learning can provide the recommendations and the prescriptive guidance in order to do that. And then, of course, Ollie, the ability to create these brand new customer experiences, these new products and these new services, something that machine learning is a key enabler for.
Yeah, absolutely. And I think it's later on we're going to share a variety of our customer stories. I'm going to show a variety of videos around all these four pillars. Customers are constantly innovating on these four pillars and improving their operations. Now, to do that, though, one of the AWS mission here is really how can we democratize this space, right? How can we give access to artificial intelligence and machine learning services to anyone out there? And we kind of take a three-layered approach here. The bottom layer here that you see here is really about thinking how can we make sure that anyone can use the right kind of frameworks. We're agnostic to the frameworks that you're using, but also how do we improve infrastructure and innovate. And I think, Dean, in a bit you're going to share about that more around how we make infrastructure, for example, cost effective for training and learning and inferring on machine learning models. We have a middle layer where we really make machine learning services available, and I'm going to talk more about that in just a bit. Even though you might be a business analyst and you want to just run your own machine learning models, you don't need to have machine learning expertise. All the way to a top layer where we say fully managed AI services, core services, industry-specific services that you can use, and we're going to dive into those in just a bit in a lot more detail. But let's stay with that bottom layer for a second. Dean, I know you love infrastructure. Your background was in this space. So why don't we have a quick look at what are we doing and how are we innovating in that bottom layer, in that infrastructure space when it comes to AI and ML?
Yeah, I appreciate you giving me this section here, Ollie, to talk about the actually underlying infrastructure that really enables machine learning for all organizations. Now, artificial intelligence, machine learning is not a relatively new concept. It's actually been around for many decades. But we've seen the prevalence of machine learning. We've seen the adoption of artificial intelligence and machine learning services across organizations, primarily because of a few key things that have happened over maybe the last decade. First of all, the advancements in CPU and GPU architectures and technology, where we've moved from more general purpose equipment and hardware to specialization of that equipment and hardware specifically designed for certain elements of machine learning, whether it's through training or inferencing. We've also seen advancements and, even more importantly, access to machine learning frameworks, where they've been open sourced and made available publicly to many organizations, large and small, so they too can take advantage of building their own models and conducting their own inferencing. And then also, of course, the cloud and open source in general has been a key enabler to see that widespread adoption of machine learning. And I really wanted to focus specifically on the hardware component because, as I mentioned, this is something that really interests me. AWS has been partnering since its inception with some of the key CPU manufacturers, specifically Intel and AMD. We've been producing the Amazon EC2 service where customers can actually elect what type of CPU architecture and CPU they would actually want to use for their particular workload. We then further partnered with the likes of NVIDIA, especially when it moved to analytics and now also into machine learning. So customers now have the option to actually leverage NVIDIA-type architectures and CPU chipsets to actually run their machine learning workloads. Now, we received feedback from customers that they actually wanted to get access to even lower cost type CPU architectures that were actually designed for the cloud. And so AWS has actually been doing a lot of investments over the last few years in this space. And we've actually made available several new chipset designs to customers, not only for machine learning, but also for general purpose systems. Whether it's things like the AWS Graviton chipset, which is an ARM-based processor, really designed for cloud-based workloads, designed for scale, not relinquishing performance, but then also at a lower cost for the customer. And then we have the AWS Inferentia chip and the AWS Trainium chipset. And the name is pretty much what it implies, that the AWS Trainium is designed for those very sophisticated machine learning models that need to be built through the training process. And then we have the AWS Inferentia chipset, which has been specifically built to then conduct the inferencing, the recommendations, the predictions from those models that are actually being built. So you can see that customers have a wide choice of the chipsets they can actually select if they choose to do so and want to actually build their machine learning workloads from scratch. But of course, Ollie, they have other options as well, don't they?
Yeah, absolutely, and thanks for taking us in so much detail through some of the underlying infrastructure, and it's great to see some of the innovation that we're doing here to really lower down the cost and make machine learning training and inference faster. But for a lot of our end customers, they don't even want to go down to that level or that underlying layer, and they say, hey, I just want to build my machine learning models myself. That's kind of where that middle layer comes in, where we have Amazon SageMaker that comes in different variations that allows you to build, train, deploy, monitor your machine learning models with your own algorithms or with inbuilt algorithms, proven algorithms, even from our partners to the marketplace, all the way to things such as SageMaker Canvas. We're going to talk more about that later, where even as a business analyst, I just have an interface where I can have a no-code machine learning experience, build my own machine learning models, but without the need to write any code or write any algorithm here or use any algorithm myself. Basically, the system does it for me. Which brings us then all the way to that kind of top layer, the fully managed AI services. And that kind of splits in between specialized and core AI ML services, artificial intelligence services here. And what that means is if I have needs around, let's say, computer vision or natural language processing or document extraction or translation services, right? These are fully managed AI services in the core here that are available for you. You can integrate them into your application. You don't need to train anything. You don't need to have any machine learning expertise. All the way to industry-specific kind of AI services, such as industrial AI services, if you need to do, if you're in manufacturing, you want to do quality control, all the way to healthcare, all the way to business process-oriented AI services. If you want to get access to the same AI services that Amazon is using for personalization, recommendation, forecasting, fraud detection, you now get access to this, through these services, fully managed. You just use them, you integrate them into your application. And that is really level setting that entire conversation about AI and machine learning, because I don't need to have the expertise if I don't want to go into the weeds of it. But I think, Dean, back over to you here. Let's talk first a little bit about the evolution on how we got here and how that all is combined with things such as data analytics, for example.
Yeah, thanks for that, Ollie. And whilst machine learning really has had that revolutionary impact to organizations, machine learning really typically comes about from an evolution of a customer and what they're actually leveraging today. And so maybe I want to actually use an example of a particular workload that you see that evolution into machine learning. Because it's important to remember that that move into machine learning it's not always a straightforward path, and it's not only involving the actual technology. There are various other moving parts behind the scenes that actually allows a customer to be very successful with applying a machine learning strategy. First of all, they need to have a very effective data strategy. Now, from our own experience, we see that time spent in machine learning is typically more focused on the data side, especially around the data wrangling and the pre-processing and the data cleaning. So customers need to ensure that they have the right data strategy in place in terms of that collection, that storage, and that accessibility to that data, making sure that the data is structured and made available in such a way that it's really democratizing access to it across the organization. Customers then need to also understand where they want to apply machine learning, and this comes to that working backwards approach that we've spoken about, where customers really need to understand what's the business outcome they want to achieve, what's the challenge they want to address, how do they want to differentiate themselves from their competitors. And once we understand that particular objective, we can work backwards from there to the appropriate technology, which may happen to be a machine learning solution, or at least machine learning being part of that solution. We need to also be able to develop our teams, making sure that we have that builder mindset, making sure that we combine the right folks together that have a combination of technical skills in the group, as well as the domain expertise as well. The domain expertise is really important because these are the professionals that really understand the actual business itself. They understand what data needs to be collected, what data needs to be analyzed and accessed. And then you have the technical specialists, which really have a good understanding of the different machine learning infrastructure that can actually be used, maybe one of the layers that we spoke about earlier. You then also need to have that champion, typically an executive from the top down who's really encouraging and reinforcing the importance of looking at machine learning as that enabler to achieve the business outcomes. Because machine learning is all about experimentation. And as we know, Ollie, experimentation sometimes does lead to failure. So the organizations really need to build a culture where they can embrace that type of failure, learn from it, and then move on. And then finally, organizations need to ensure that they're removing that undifferentiated heavy lifting. when it comes to machine learning, taking advantage of some of those ML services we're going to talk about, maybe the AI services themselves as well. So customers can actually focus on what's going to deliver value to their business rather than trying to just keep the lights on when it comes to the machine learning infrastructure. So let's look at that example I spoke about. And the example I've used is a e-commerce platform. And it's not just because I'm from Amazon, but it's actually a platform or a workload that many people will actually be very familiar with. So when e-commerce platforms were being designed way back in the day, many, many decades ago, typically you would have this very big monolithic type application that provided all the different functionality in the e-commerce platform, providing the UX or the interface, as well as the back-end support for all the different types of transactions of purchasing and providing the catalog, etc. And so typically you'd couple that application with a relational database. And so that relational database will hold all the data that is comprised of that actual e-commerce platform. Now, over time, what organizations have discovered is that by breaking down that monolith, maybe into microservices or maybe even mini monoliths, allows them to move a lot quicker when it comes to innovating and iterating on that e-commerce platform. But what it also introduces is the ability for those different teams looking after now the different components of that application to have their own choice of what data platform they want to use for the data sets they're collecting and analyzing. So they may continue to use a relational database for all the transactions, all the purchases, for example, that happen through the e-commerce platform. But you might have the team that looks after the product catalog, who want to maybe use a key value store rather than a relational database, because the product catalog doesn't have many relationships in it, simply the list of items and a description, and maybe the inventory. But then you also might have a recommendation team. And the recommendation team feel that a graph-type database, which basically maintains the large number of connections or relationships between the different entities in the ecosystem, where a relational database or even a key value store database would not be sufficient. So we can start to see that we now have choices of different data platforms to actually use to support our e-commerce environment. But now that we're collecting all this different information, because now we've evolved to maybe collecting things like log information, application, clickstream data, maybe even IoT sensor information, we now have the option of choosing these different types of purpose-built tools to effectively collect, store, and analyze the information. But now we see an additional problem. You now have these different types of data platforms that are actually collecting these different types of information. What if we want to take it one step further and we want to start driving insights in terms of for example, how our customer satisfaction scores trending quarter over quarter? Fairly easy to do. You probably actually inspect a database for that. But let's look at more maybe complicated questions or queries from the business, such as what customers should I target for promotions, or how can I do forecasting of the sales? In order to do that, we need to collect that information from a wider range of data sources, now that is spread across different databases. And this is where things like the data lake actually comes in. And the idea behind the data lake is it's that aggregation point, that consolidation point that various tools can actually use to analyze data in different ways. And it's a very effective way to ensure that you have the right control and compliance across those different data sets. And this is where we then have the natural evolution into machine learning, because customers now have that ability to leverage the combination of data that has been collected across those different database platforms, aggregated into the data lake, and start building their machine learning models through training now that they have access to all of these different types of data. And so customers can then start leveraging their different business intelligence tools, building the dashboards they need to build, setting up analytics processes for the business, but leveraging what's available in that actual data lake. And that leads us to that prediction, because like I mentioned, you can now start building and training your models in machine learning because of that vast array of data that you now hold at your disposal. And you can see how machine learning can then have that significant impact across the business by being able to provide those different predictions. So it's all about that end-to-end data strategy, from the actual ingestion point and storing and accessibility of that data through to the analysis, the visualization, and then finally to the predictions, Ollie. And so customers that we've been working with over the last 15, 16 years have actually gone through this natural evolution, where they've started typically on the analytics side to get their data strategy right. and then having that evolution, that natural evolution into the machine learning side. And so today, Ollie, we have over 1.5 million customers that are actually leveraging various different services from AWS, both on analytics and machine learning, across different industries and across different environments. And Ollie, I'd love to hear more about the typical use cases we're seeing of machine learning have an impact across different organizations.
And thanks for taking us through this. I think it's really important to get the foundations right. And now in the next section here, what I want to focus on is really, what are some of these business outcomes that some of our customers are driving with the help of data, with the help of artificial intelligence and machine learning. But kind of before getting into that, let's just quickly recap. Earlier, we started off by saying there are kind of 4 pillars that we're looking at here. We're looking at how can we optimize our existing business. I'm going to give you examples there. How can we make better, smarter, or faster decisions here? How can we add new capabilities to existing products? I think what you described there was a good example, a better customer experience, all the way to inventing net new products. And what you'll find is I'm going to share a variety of use cases here with you, but you see that this spans across pretty much every industry out there. No matter if you're in manufacturing, automotive, you might have predictive maintenance, or in retail or manufacturing, you might have demand forecasting. You might have fraud detection models, especially for financial services or online e-commerce application, credit risk predictions, right? All the way to extracting and analyzing data from documents, for example, for KYC in healthcare and legal, in finance. Computer vision. I'm going to give you some cool examples here around healthcare, pharma, manufacturing, self-driving cars, autonomous vehicles, all the way to personalized recommendation, the media entertainment space, retail space, all the way to churn prediction, again, retail, education, all kinds of software and internet companies out there. So lots of different applications here, but let's have a look at a few. So let's take, for example, the healthcare space. So you might have heard of Moderna. Moderna Therapeutics is actually using AWS and the machine learning models to automate their lab and manufacturing process here to develop their mRNA vaccines, which you might be familiar with right now, given that they also developed one of the COVID-19 mRNA vaccines. Or take GE Healthcare, for example. They learn from thousands of medical scans to detect anomalies on X-ray analysis, on MRI scans. Again, that allows us to more accurately and efficiently allow radiologists to maybe find prioritize patients that need immediate attention here. Or take retail, right? Lotte Mart coming from Korea, but they have 189 stores across the region. Over 600,000 daily shoppers, and they were looking into what's the business outcome I want to drive. I want to increase my customer loyalty by improving customer engagement. So I want to give better personalization and recommendation, improve coupon recommendation service with stuff like Amazon Personalizer, our fully managed AI service, then like sales history, product metadata, user profiles, etc. Found that they had a 5x increase in response to those recommended products, and that increased even their product purchase of up to net new of up to 40%. Or take Domino's Pizza. If you're hungry and you order a pizza delivery, right, you want that pizza to arrive as fast as possible, right? So again, a good customer experience is if I can reduce the delivery time of that pizza. Now, what Domino's Pizza did specifically here in Australia, for example, but also globally, they're looking into, or they're using basically machine learning models on top of AWS to predict the likelihood that a certain order will be placed. And based on that, preempt in the kitchen, basically, which pizzas should be produced with various color indicators. And that allowed them to bring down, in an example store in Australia, for example, the average delivery time to under 5 minutes from placing the order online to having the pizza in front of your doorstep. So that's a really great customer experience. Or take something like the Port of Vancouver. Right? Here again, we have containers, that basically need to be tracked, need to be placed. So wouldn't it be great if we can do that more efficiently? Right, so one great thing to use here is, for example, computer vision. Specifically, they work with Deloitte to use our AWS Panorama service, which allows you to have computer vision models at the edge, so an actual physical appliance that runs at the edge on that port. And again, this is done to optimize their ground operations and expedite container inspection, for example, and of course, while of course keeping data privacy in mind by doing that computer vision or running this computer vision model on the appliance itself at the port itself. But talking a little bit about computer vision, take something out of the Amazon fulfillment centers. What you see here is a video of something that we implemented after COVID-19 pandemic happened. We were looking into what can we do around reducing physical contact to avoid a transmission of the COVID-19 virus. So basically social distancing, as we like to call it these days. And what you can see is a computer vision model that basically looks at what's the distance between the individuals as they're walking around. If you get too close to each other, there are audible sounds or alarms that are basically being raised, like, hey, you know, move a little bit further apart. Again, the idea here is the business outcome is how can we keep our employees safe? How can we avoid a virus transmission here by improving social distancing by having these measures in place? Now, that can be even taken further. What you see right here is from a partner company, a partner of AWS, I should say, called BigMate, and they have a system called Warny. And what Warny does is it basically does dynamic geofencing, again using computer vision. So you can see it not only recognizes the individuals that are moving around and the machinery that is being operated, but it also understands what is the allowed distance. And if I, based on that dynamic geofencing, I can again sound an alarm or maybe even go as far as stopping an equipment to operate to avoid any kind of danger. So again, ensuring employee safety, reducing the risk of accidents bound to happen by using stuff such as computer vision. Another example would be, what if I want to improve the experience for something such as Formula One, for example? With Formula One, what they basically did is they said, you know, could we improve the fan experience by providing better insights to them in real time when they're watching it on their TV screens? And so what they did is they basically equipped F1 cars with 300 sensors that generate 1.1 million telemetry data points every second. And at the bottom you can see some of these sensors that are being installed. But again, here they bring in machine learning data now to also take 70 years of historical race data, match it up, and then do predictions based on, you know, who could maybe take the lead, who's better braking in certain bend, etc. Again, the business outcome here really creating a more engaging fan experience for the viewership. And sticking a little bit with some of these sensors, some of the other interesting things that you can do nowadays is a technique called sensor fusion. So you use multiple sensor points, such as, for example, a LiDAR sensor, which is a laser that goes around to understand distance between physical objects and then create a 3D point cloud. What you then can do is you can match it up with computer vision models. And you can see that here. So we have an object detection model, detects a car. We match it up with a LiDAR sensor, you know, so we know the physical distance, and we match it up with computer vision to have an even more accurate representation or understanding of the physical world. Now, why do we do that? Because that can be useful if you want to do things such as building an autonomous vehicle, a self-driving truck or a self-driving car. Take our customer, Aurora. Aurora is specifically doing this. So they build complex object detection models for autonomous driving, specifically trucks here, for example. So they use some of their LiDAR sensors, they map it up with computer vision, they match it all together and create this model here. And by the way, by doing that, of course, on AWS, they also reduce the development life cycles of these models from weeks down to less than a day, accelerating again their pace of innovation. And you can see how that then looks, you know, if this model is applied here. You can see a truck navigating in somewhat difficult situations, and you can see how the LiDAR sensor and the cameras that you see on top are basically mapping out this entire environment here and safely navigating then either way fully autonomously this truck around, or at least give warnings or have assisted driving. So again, great outcomes that can be done here by mapping things such as IoT sensors, you know, learning about those sensors, bringing in computer vision. But another larger customer of AWS is Amazon itself, actually. So Amazon is a customer of AWS too. So let's take a few examples of the broader Amazon space, specifically some of our retail operations and how we are driving business outcomes with the help of artificial intelligence and machine learning. So let's zoom in first into some of our fulfillment centers here. Now, what you can see here is basically a video of one of our fulfillment centers that is operated with Amazon robotics department's Kiva robots. Now, what they do is basically help with the picking process within a fulfillment center. So you can see that here, it drives under the shelf, lifts up the shelves and bring it to the packing station. And we do that for two reasons. The first one is an obvious one, maybe make sure that the picking time is reduced or we pick more efficiently. But secondly, and that's the more important scenario here, is we can actually compress the size of these fulfillment centers by storing more goods closer to each other with this storing mechanism. Now, of course, you can imagine the robots, have sensors and they need to learn, etc. But there's another interesting element of AI being used here, specifically computer vision. So the first thing that we're using here is basically a computer vision model that looks at those bins and understands what's the remaining space that we have in those bins and optimizes basically what we're storing inside. Remember, that goes back to our business outcome. We want to compress the space that we require in a fulfillment center. Less real estate cost, it means reduced price, it means we can give those cost savings back to our end customer. In addition to that, it's also an example of increased operational efficiency. That computer vision model can also give visible cues to the fulfillment center associates when they do the picking and packing here. And you can see that on the bottom right corner here with these purple kind of lights that shine onto the buckets that need to be, where products need to be placed or taken out of to decrease that cognitive load on the FC associate. The other thing is, a good customer experience is if I can get goods shipped to me as fast as possible, which means we need to have these goods in, warehouses or facilities that are close by to our end customers, and we need to have it available, right? So that means we need to have an efficient supply chain that understands these components. We automate our supply chain completely end to end, and that starts with forecasting. So we forecast for over 400 million products daily where and what we need, and based on that, over 99% of the entire inventory is ordered completely automatically. And then even the machine learning model further looks into, what's the optimal inbound placement, where's the kind of right fulfillment center to place this kind of goods, for example. Another example could be, what if I want to improve my customer experience for folks to easier find, let's say, for example, if we talk fashion, right? Find the kind of right pants or whatever kind of fashion you want to buy. And we figured that wouldn't it be great if you see something that you find nice, that you want to see something that has a similar fashion. So this is, for example, something called Style Snap. Style Snap is a functionality that we introduced. You can take an existing picture that you find maybe on the internet or that you've taken with some of your friends, and then it looks at what that person is wearing, and then again runs it through computer vision and a machine learning model to give you accurate kind of results here of something that could interest you if you like this style. Now, the other thing, talking about a good customer experience, one of the things that we're looking into, how can we improve delivery of actual packages, either way in between fulfillment centers, but also specifically delivered to your home and in front of your lawn, in front of your house, for example. And so you might have heard of Amazon Prime Air, where we have drones that are able to actually deliver packages even to the footstep of your door. And we went to many different iterations where you see here all the way on the left-hand side the latest kind of drone iterations that we have. Now, what I want to focus on next, though, is one of the very important thing here is safety, right, if we operate these drones. So what are we doing to actually use AI and machine learning models, such as computer vision, for example, to ensure safety here? So let's zoom in here in a little bit more detail. So one of the things that we're doing is, for example, photogrammetry. So basically use pictures or computer vision of the cameras and then render a 3D point cloud. So that's kind of what I talked about earlier, to understand the physical objects, perform image segmentation, for example, do a VSLAM, which is visual simultaneous localization and mapping. That's a mouthful. Now what it means though is that I use cameras to visually map out where I'm at and navigate around, and then use deep neural networks specifically with computer vision to understand, is there a person, where do I deliver this package, for example. And this is where the safety outcome really comes in. So what you see here is, for example, actual drone footage of trying to deliver that package. If a person goes into the space where the delivery should occur, the drone is waiting, it's not going to place itself next to it. And at the bottom right corner, you can even see a video that detects basically a cloth hanging line there that it doesn't want to run into. So that's as accurate as these models really become to ensure safety of the individual. So again, outcome here really driving also safety, and safety being a very important thing here, and using computer vision models and other AI models to do so. Now, lastly, let me give you an example of Amazon Go. Now, if you're not familiar with what Amazon Go is here we wanted to create a wonderful customer experience where we say, you walk into a convenience store, you take anything off the shelves you want, and then you just walk out and we automatically charge you based on what you took off the shelves or consumed, even within that store. And how do we achieve that? Well, with the help of computer vision. So we have lots of sensors in the store and lots of cameras hanging in the ceiling. And here you see actual footage now of that first store in Seattle of how folks are moving around. The cameras are basically understanding how folks are moving around. You can see this was during lunchtime pre-COVID where it was really busy. People are moving around and then cameras identify, what are folks taking off the shelves, for example. These computer vision models can help them understand exactly what's picked off the shelf. So again, driving the business outcome of a wonderful customer experience, walking in and out and being able, to get your sandwich for lunchtime in 10 seconds or less maybe. Now, lots of examples here, but I'm going to pass it back over to you, Dean, to really talk a little bit about how we also make machine learning accessible to pretty much everyone out there. So take us through that, please.
Thanks for that, Ollie, and really kudos to you to be able to really talk about that wide variety of use cases where machine learning has been applied across many different organizations, including in Amazon as well. And sometimes there's that, I wouldn't say misconception, but just that observation that machine learning is only applied really to that end customer, to that end user experience. But at AWS, we're really focused on putting machine learning into the hands of everyone, whether you're a technical person or a non-technical person. And we spoke about those 3 layers of the machine learning stack as being an important component to actually achieve that. Because when you look at a typical data platform in an organization, there's actually many roles involved to make that data platform successful. And so if we want to maybe drill down into some of those roles that typically apply and how machine learning could actually be leveraged in those different roles and those different functions. So typically you would see these roles comprised of the business decision makers. Now the business decision makers are the ones that actually need the right data to actually direct the business into the right area to make those critical business decision points. They need readily accessible data, and the best way to interpret that data may be using something like machine learning. Then you have your developers. Your developers are quickly iterating on the software development platform, whether it's through new feature sets, new products, or maybe just addressing certain fixes and issues. So as that grows, being able to do that in a manual level actually becomes unscalable. And so how can they use machine learning to actually address that? You have your data engineers and your data scientists. These are the folks that are really focused on building those machine learning models, optimizing it for the business. So how can they leverage technology to actually do that in a very efficient way? And then you have your cloud and security engineers. So these are the operations folks, the security folks. How can we ensure that the infrastructure is readily available to the other roles in the business that require that infrastructure and ready access to that infrastructure in order to be very efficient? So let's drill down into some of those roles. Now, we don't have time to cover all the different roles, but we've picked about 5 or 6 of specific roles where services from AWS can really add that particular value. Now, in the business decision makers space, so again, these are the folks that actually make those decisions based on data they're receiving and need ready access to that data. We have services like Amazon SageMaker Canvas. And so Ollie actually alluded to this earlier in the presentation, talking about how Amazon SageMaker Canvas provides the ability for non-technical users to build their visualization leveraging machine learning for predictions, to provide those recommendations and that prescriptive guidance. And so you can be a non-technical user and still take advantage of machine learning models. Then we have Amazon QuickSight Q. So Amazon QuickSight is our business intelligence tool, our visualization tool that can analyze the data that you've been collecting to provide things like forecasting and identifying trends, maybe looking at how to personalize the end user experience. And the Q part for Amazon QuickSight Q is the introduction of machine learning specifically focused on natural language interaction. And what that actually means is the business decision maker can interact with the data that's being collected in a more natural way, the power of normal conversation, whether it's through typing it through a console or some type of interface, maybe interacting with some type of voice interaction. Business users can now get access to the data that they need without having to relearn a business intelligence tool, understanding flowcharts and understanding different tools and buttons that they might need to collect. So we've already seen the accessibility of natural language maybe on your mobile phone when you're interfacing with your mobile phone voice assistant, or maybe you're interfacing with that Alexa device at home. So taking that same concept and applying it to business intelligence. And one such customer that's doing this is the NFL. So we've actually been working with the NFL for many years now on their Next Gen Stats initiative. So Next Gen Stats really takes the viewing experience of the NFL football to the next level, where it actually can provide in real time predictions and analysis of plays and movements in the game that viewers can elect to actually observe and watch. And this data is produced by collecting a lot of information that's actually happening on that sports ground in real time through things like IoT sensors and through things like computer vision. Well, they've taken it to the next level by actually taking all of that data that's been collected and providing Amazon QuickSight Q to the businesses, the team owners and other officials across the game that can actually analyze all of that information using the power of natural language interaction. So those officials who may not be technical in nature can actually start getting the insights they need, again, without having to relearn or learn about a new tool. Then we have the developers. And so the developers are those that typically don't have machine learning specialization. They may not really understand fundamentals around machine learning modeling, around algorithms, around training, around the deployment. But they still want access to machine learning capability to make their roles a lot more efficient. And so over the past few years, we've introduced services like Amazon Code Guru. So Amazon Code Guru is the idea where we can use machine learning based on our own experiences at Amazon, where the technology will actually provide a review of the code that you're actually producing for your software application. So rather than having to have developers sitting in a room reviewing code line by line, which absolutely does not scale, you could leverage something like Amazon Code Guru, which can identify certain potential issues in your code, whether it's things like code use or library use that's not optimized, or maybe certain vulnerabilities that actually might exist in your code. Because this is an automated platform, you can actually leverage Amazon Code Guru in your CI/CD pipeline as part of your testing. Then we have Amazon DevOps Guru, and Amazon DevOps Guru is really focused on the various components that makes up your CI/CD pipeline and the resources that it deploys. As your applications become more sophisticated, it becomes very hard to keep track and monitor the behavior and the ongoing status of those various components. And so DevOps Guru uses machine learning technology based again on Amazon's own experience to provide a visual dashboard of potential issues that may exist in your entire pipeline. Maybe identifying certain bottlenecks that actually might exist in your database, for example, with the Amazon DevOps Guru for RDS feature we just released. And then finally, we have the Amazon AI services, which Ollie actually mentioned. These are the services that are essentially API driven, where developers don't need to have an understanding of machine learning models. They simply need a computer vision technology. They need the ability to analyze an image or a video. They need to be able to convert a text to voice or a voice to text. They need to perhaps provide some forecasting into their application. So this is where we use the Amazon AI services. And one such example of a customer that's doing this with the Amazon AI services is the NIB Insurance customer in Australia. So this is an organisation that does not have any in-house data science or machine learning specialists. But they wanted to look at using machine learning to deliver a more optimal customer experience to their end users, specifically when the users want to contact the customer service centre. And so they introduced a few bits of technology to actually achieve that. One with the Amazon text extract service, which essentially allows their customers to submit claims and have it all automated in terms of processing. Because what text extract will do is extract the relevant contextual information from the documents that are submitted, most likely online, and actually then go through the claims processing workflow. They've been able to achieve a majority of their claims processing in this automated way. And so this basically alleviates that need from a lot of their customer service agents, the humans that can actually focus on the more detailed or in-depth conversations with their customers. They also leverage things like chatbots using their NIBI chatbot, which basically interacts with a customer rather than using a customer service agent. And about 65% of their customer interactions are using NIBI today. But the important thing to remember is they're actually using AI services because they don't have any of that in-house expertise. And so move on to the data scientists and the machine learning engineers. And so services that are available to these type of folks, these are the ones that are essentially understanding the data that's being collected and building the necessary models. So we have services like Amazon SageMaker Studio, essentially an integrated development environment, an IDE, that visualization tool that these roles can actually use to build their entire machine learning pipeline with SageMaker, from the training all the way through to the deployment. So that's that one single pane of glass to actually create that entire workflow. And then, as we mentioned at the start, we have this infrastructure and frameworks as well. So the ability for machine learning specialists to get access to specialized hardware in CPU and GPU and accelerators, or access to the frameworks they need as well. And one such customer that's doing this is Viz AI, an Israeli-based organization, and they're doing something really significant that's making its impact across the urgent stroke care area. So when, in the unfortunate incident where somebody does suffer a stroke, time really is critical. Each second that goes by can cause further damage to that patient. So what Viz AI is attempting to do is basically optimize that review or the triage process where it's actually all automated. So after the CT scan is actually conducted, they're using machine learning technology to actually do the analysis of that CT scan and provide an immediate recommendation to a neurologist or a neurosurgeon to take the appropriate action by sending the information to the mobile phone. What this does is it avoids the need for a neurologist or a neurosurgeon to actually do the review of the CT scan before recommending the next step. Sometimes this type of thing, depending on the availability of that neurologist, could actually take a couple of hours. And so they're looking at reducing this entire process to just several minutes. And this can be a significantly beneficial outcome to the patient that they're working with. And then finally, we have the data engineers and the machine learning ops engineers. And these are the folks that are really focused on the modeling, the training and the building of these models that are going to be used for the inferencing. So we've got services like SageMaker Ground Truth Plus, which basically provides specialist skills, the access to specialist skills to actually do a lot of your data labeling, especially for your image analysis and your computer vision. So you know that if you work in a niche market, that you have access to people who really understand the images that they're analyzing and processing. And then database developers for machine learning, where we've integrated access to machine learning capabilities into services like Redshift, our data warehouse, or Aurora, our commercial database, where the developers can actually use their more familiar SQL language, SQL, to access machine learning models through that particular service. And then we finally have the cloud and security engineers. And the cloud and security engineers are the operations folks, making sure they have access to services like Amazon Guard Duty, which actually can do a review of all of your AWS resources and detect any suspicious activity or maybe security vulnerabilities like AWS credentials out in the wild, or maybe ports and documents that are actually open. So we can see that there's machine learning capabilities being put into the hands of not only the end application, but every other role across that data platform. So I'd actually like to hand over to Ollie, who can take us through the machine learning operations side. And there's this new concept around automation of machine learning workflows. So Ollie, maybe talk us through how machine learning ops engineers can really apply certain methods to make their life a little bit easier.
Yeah, great. Thanks for taking us through here, Dean. And again, it goes to show that no matter what kind of persona you are, there's services available for you to make your life easier. And so, if we talk about machine learning, it's similar to any kind of software engineering practice. We generally don't train one model and we're done, right? We constantly want to iterate. We want to improve our model, and so we want to obviously streamline that kind of life cycle. Now, what do I mean with that, though? What's the development life cycle of machine learning? Building, training, deploying. That's it, right? Are we done here? No, of course not, right? We also want to monitor how that model performs at any point in time. We want to maybe have a variety of different versions of that model and then monitor it. And based on monitoring that model, we might want to retrain some of the machine learning models in a different way so that we can get a better output here. Now, in addition to that, sometimes we might say, based on what we just learned, we even want to go back to the build stage where we say we don't just want to retrain it with new data, but we want to completely rebuild that machine learning model to have a different variations because the real life or the real world data is maybe changing, so we've got to retrain and rebuild it with a different algorithm. Now, what that then leads to is obviously good working and accurate machine learning models that effectively then leads to happier customers, which in effect then leads to more customers, which means more data, which then again means more data to build and train new machine learning models on top of it and make the experience even better. So you can see we kind of run in that life cycle over and over and over again, and for a variety of companies, that might be even a daily or even more frequent kind of process. So one of the key points here is we really want to automate some of this out. Which brings me to kind of the key tenets that we want to look at to optimize your ML ops lifecycle. The first one up here is really about creating automated and reproducible machine learning workflows. So the way you maybe label your data, maybe you train it, etc. And then when you have models, you definitely want to manage these models with a model registry. Every different model that you create should be in a model registry, and we're going to talk a little bit in what a model registry is in just a bit. We also want to make sure that we enable all of the delivery of these machine learning models completely through a CI/CD pipeline, or even with infrastructure as code. So anything should be fully automated, a full automated pipeline. And like I said, we want to monitor the performance and the feedback information of all of these models. All of these four tenets are super important for me to operate effectively machine learning AI models. Now, one service that can really help me here is Amazon SageMaker Pipelines. So SageMaker Pipelines is a fully managed machine learning CI/CD service, continuous integration, continuous deployment service. So it centrally manages each step of these workflows, and you can even do that visually. We have built-in templates that you can choose from. You can also share these workflows and rerun them and even compare them visually. See, this is a great way to kind of have reproducibility whenever we run these pipelines again. Then I did mention we want to have a model registry. Well, what does that mean? Well, similar to other software engineering disciplines, we want to version control our code. We also want to version control our machine learning models. A model registry is a centralized tracking system that stores that lineage, that versioning, the related metadata that comes with these machine learning models. And that related metadata can be super important because it might be able to capture our governance data that we require for auditing purposes, especially in a regulated industry. That could be things such as who trained and who published that model, which data sets were used for training, What were the values of metrics that we measure to understand if a model is performing well? When was the model deployed to production? So all of that metadata can be in the model registry, so it makes it easier for us to also govern my machine learning models. Now, in addition to that, you do also have the ability to approve models. If you use the model registry of SageMaker itself, you can build models, version it, and then you can say, okay, this is now ready for deployment. So you can even have a variation between whoever is building the models and the ones who are deploying the models out, and you can improve them as such. And in addition to that, when we talk about deploying machine learning models out, you can also deploy multiple variations at the same time. We often call this a multivariant endpoint, and obviously Amazon SageMaker does allow for this. So you can actually, and you can see here a little code snippet that you can put in your code pipeline where you say, I want to do sampling of 2 different variations of my model that I shoot out, and maybe some of the traffic, 1% of the traffic I send to a newer model and the rest I send to another model, and based on that I can then decide which model maybe performs better, which obviously allows for blue-green kind of deployments or variations, but also allows you to overall understand if your model is performing effectively. In addition to that, SageMaker comes with a model monitor, so you can understand and identify model drift when and if it is happening, and based on that then take action. So again, a model that performs very well today might perform not so well tomorrow, because suddenly we have different kind of users on my platform, different kind of data sets available. So it's good to constantly monitor my models here and detect drift. Now, lastly, one of the other things that you also want to put into your workflow is the human review functionality. So sometimes you might have machine learning models, or you even use some of our AI services, and you say 95% of whatever, or 99% of the requests that are going through, we have a high confidence that our machine learning model can make the right prediction here, shove it to the machine learning model or the AI model, and when that confidence is low, then I can maybe pass it back to a human review workflow. So Amazon Augmented AI, or A2I in short, allows you to do exactly that. Basically have a human review that comes in whenever the confidence level is low for the AI or machine learning model. Now, lastly, one tip that I would also give is we want to balance the needs between our machine learning builders, our data scientists, and cloud IT. So we want to stay agile. We want to give self-service access to our machine learning builders, data scientists, so they can quickly build their models, try things out, respond to change. But at the same time, this should be governed through cloud IT models. So when you use AWS, you have all these security and compliance controls, spend management, operational controls that you can use right here and balance those needs out. One last thing, though, is also about training people up. And to talk a little bit more about that, let me see if Dean is still on the line. Dean, do you want to share with us a little bit on some of the things that we're doing specifically around training?
I'm indeed here, Ollie, and yes, we have a commitment at AWS to ensure that we are providing the right knowledge to our customers. And in fact, we've gone a step further, and we have a commitment that we're going to be looking at training up over 29 million professionals on machine learning by 2025. And hopefully the event today will be that small contribution to that number, Ollie. And it is a learning experience, AWS Innovate, but we do have other learning experiences that are available to our customers as well. Now, customers who are looking for hands-on practical exposure to machine learning can maybe take a look at things like the Deep Racer League. It's an opportunity for customers to actually be competitive in a league where they're actually using machine learning in specific context of reinforcement learning, a type of learning process with machine learning. And they're actually using those models to control an autonomous car around a racetrack, whether it's virtual or physical. But it's a great way to actually get started with machine learning. Even if you have zero machine learning experience, there are actual modules available for you in that Deep Racer League. We also have our training and certification team that's working very closely with third-party online training resources, as well as with our machine learning university. So this is the ability for customers and individuals to get access to free online-based training that's self-service to really get started in the machine learning ecosystem. It provides access to very useful material that's very relevant for some of the services that we spoke about today, from SageMaker through to the AI services. We've also partnered, like I mentioned, with the online training provider Udacity, who offers the machine learning nano degree. And so we've offered some scholarship programs for individuals who want to undertake that opportunity. And then finally, Ollie, we have the Amazon SageMaker Studio Lab. And the Studio Lab provides individuals access to Amazon SageMaker with actually no AWS account. You just need an email address. And this essentially has a set of free tier components where you can start building your models and training, building and training your models, as well as deploying in machine learning. So a wide variety of options that customers can actually use to enhance their learning experience and continue on that machine learning path.
All right, great, and thanks for taking us through that, Dean. I think it's great again that we not only looking into training people up. You shared all these different personas and how we make it easy and approachable to have AI and machine learning, even without the expertise. But if you want to go deep, plenty of options to really learn from that here. Now, Dean, I want to thank you again for joining me here during the opening keynote. I think I'll have you back later during the closing keynote. So thanks already for joining me here.
Absolutely, Ollie. Yes, we'll talk again at the closing.
Thanks. And now, with that in mind, I also want to remind our audience that we do have our AI and machine learning resource hub here with AWS Innovate. So you can either way scan this QR code on the side or go to the URL where we have a lot more resources, from ebooks to other that look into machine learning and how you run it, etc. Some of the best practices. So go and check out that resource hub. Very interesting for you to learn more. Dean already hinted at training and certification as the AWS training and certification teams and programs that we have. So go to aws.training. Lots of training available for you digitally online, so you can learn it at your own pace. There's machine learning specific training, and of course you can then validate your expertise through the AWS certification program. I also want to encourage you to provide us with feedback. So whatever worked well today with AWS Innovate, whatever we can improve, let us know either way through the platform here or through some of our social media handles here, or email address that is provided here. So please provide us the feedback on what we can improve and what you want to hear more about. Which brings me now to the end of this closing keynote here, but it doesn't stop here. This is just the beginning. So we have prepared for you plenty of different breakout sections here. So have a look at what is the right breakout section for you. They're business-oriented kind of breakout sections, more builder-oriented breakout